Hi guys, bear with me a little bit. I'm going to try to get through this lesson quickly so that you can work on it. Um, this lesson I know we did in Algebra 1, and I know that's like 100 million years ago in teenage years. So hopefully some of this you'll remember a little bit. It's transformations of functions, and we're just going to talk about linear, quadratic, and absolute value functions right now. So what I have up here is a linear function. And this is the parent linear function right here. And you can always, always, always figure out what it is by doing an XY table. Okay, if I put in a, whoa, my handwriting got really sucky. If I put in a 1 for X, I get out a 1 for Y. That would be right here. If I put in a 2, I get out a 2. If I put in a 0, I get out a 0. Okay. Now, linear functions don't have a whole lot of transformations to them because they're just a line, so their up down is the same thing as their left right. So we'll just do a couple of different ones on here right now. I'm going to switch colors. Okay, if we're going up or down, that's just tacked on. So f of x equals x plus 2. That is going up 2. Okay. So you can always just start with this and then take every point and put it up 2. This point I'll put up here. This point I'll put up here. Okay? And you can draw your line like that. That would be the graph of x plus 2. Okay? Likewise, if you are unsure on how to do that, you can always do an xy table. Okay? If I put in a 0, I'm going to get 2 out. And you can see that that happens. Okay? So that's going up. If you're going down, it's going to be a minus. So x minus 3. That one's going to be down here. And almost impressed with my straight lines today. Reflecting across the axes, I guess. So if I put a negative in front of it, this is going to be reflected across the x-axis. So your 0 will stay in the same spot, but now your 1 becomes negative 1, and so forth. So that would look kind of like that. There goes my good lines. Hoofda. Okay. Of course, there is some vertical stretching and vertical compressing. And if we are going to compress, it's going to be less than 1, so 1/2 x. And if we're going to stretch, so this is a vertical compression. And if we are going to stretch, it will be greater than 1, so like 5x. And that is a vertical stretch. Okay. And what I would do, I would always suggest with compression and stretching is to use an XY table because it's really hard to know exactly where they're going to go. In this case, because it's linear, it's not quite as hard. Your 1/2 x is going to be something like this. And your 5x will be something like this. Whoops, yeah. Okay. So we will move on to the, what are we doing next? The quadratic, because that has a lot more information with it. Okay, so here we are. And we have x squared. That's our parent quadratic function. And I went ahead and drew this out already because it took me like 6 tries to get it even halfway close, and it's still not good. Okay, that's the parent function. You can always do an XY table. You can put in a 1, you're going to get out a 1. If you put in a negative 1, you're going to get out a 1. If you can put in a -2, you're going to get out a 4, etc. Okay, if you don't know what these are, but they are in your notes. Let's talk about the different transformations now. If we're going to go up 1, then we're just going to tack on 1 at the end. Okay, up 1. And there, every single point goes up 1. Yep, I knew it wasn't going to work. Wow. Okay, so if you have subtract 5, that's going to be down 5. Okay. If you have, this is where it gets a little bit fun. If you have parentheses, it's inside the parentheses. This is indicating it's a transformation left 1. So inside the parentheses is kind of crazy. Okay. It's the absolute opposite. If you have inside parentheses and you're subtracting, this here is indicating that it's going right 3. So I'll do that one up here. That is just your original blue function, but now it's right 3. So every dot is moved over 3. Okay. When we do vertical compression and vertical stretch, that's on the outside. So if I had 4x minus, or x squared, I don't need the parentheses there, but I guess I did it. This would be a vertical stretch by 4. And this I would use an XY table on, just to make sure I'm getting it correctly. Right? Same thing as if I had something less than 1, if I had 1/3 x squared. Again, that's a vertical compression. It'll flatten it out, and I would use the XY table on that. When we talk about horizontal and vertical compressions, anything horizontal, when we talk about horizontal stretches or compressions, anything horizontal is going to be backwards. So my x's, it's going to be inside the parentheses. If I have a 3x inside the parentheses like this, this is actually going to be a horizontal compression by a factor of 3. Again, use the XY table for that. I will show you what a horizontal stretch looks like. It looks like a fraction. It might be 1/2 x squared inside the parentheses, horizontal stretch, or it might look like, I'll do it again, x squared over 2. Okay, so that's still a fraction. These are the same thing right here. Okay, horizontal stretch. Let's see, I need to move up my paper a little bit. Let's talk about reflections real quick. If we're reflecting across the x-axis, the negative sign is just going to go in front of the whole thing. So negative x squared. Okay, that's just going to look like this blue one up here, but reflected across the x. So now it's just going to be down this way. Good grief. Okay, and if you have the negative inside the parentheses, that's going to reflect across the y-axis. Okay, I'll write these on here. Reflect y, reflect x. The neat thing about some quadratics is that if you reflect across the y-axis, like this one here, actually all the red and the blues, if you reflect across the y-axis, it's just going to be the same graph again. Whereas this green one, if you reflected that one across the y-axis, that's going to end up over here in quadrant 2. Okay, so that one's not. And your reflection question actually has something to do with that, so I thought I'd bring that up. Lastly, let's talk about absolute value functions. And note I put your assignment up here, and yes, you'll be graphing, but it will be so much fun, you won't even notice it's work. Okay, so absolute value function, this is the parent function, and it looks a lot like, all the transformations look a lot like the quadratic, because the absolute value signs, you can think of those as brackets, parentheses, whatnot. So if you have a negative in front of your absolute value of x, that's just going to be reflected across the x-axis. So that's going to look like that. If you have a negative on the inside, that's going to reflect across the y. So that is going to be the exact same thing. If you have a plus or a minus tacked on at the end, right? So if I have absolute value of x plus 5, that's going to go up 5. 2, 5. If I have it down, it'll be a subtract. Down 1. Okay. Vertical stretch and horizontal stretches and compressions. That we'll do in green because we love green. So vertical stretch, whole number on the outside, that's a vertical stretch. Use an XY table. Vertical compression would be a fraction on the outside. If you deal with horizontal compressions and stretches, that's going to be on the inside and it's going to look wacky. So a 2x on the inside of the absolute value signs is actually going to be a horizontal compression. Okay? So horizontal compression and vertical stretch are very, very similar. Okay? And depending on the other transformations done to it, they could be the same. And if we have a fraction, that is your horizontal stretch. Okay, so it's being pulled apart horizontally. I probably forgot something here, but that's a general idea. I don't want to keep this too long. That's already almost 13 minutes. So here's your assignment. Good luck. Work together. See you guys hopefully Friday.